trees and forests, as they're growing, they take up CO2 and they use water and the energy from sunlight to make their own food, make their own sugars through the process of photosynthesis. They're taking up carbon dioxide from the atmosphere and incorporating that into their leaves and roots and wood. The growth that we see in tree rings can give us an idea of how much carbon is taken up during a given year. So the overall goal of our research project is to help quantify the feedbacks between forests and climate. So climate can impact the amount of carbon that forests are taking up in a given year, and if forests take up more carbon, that can then feed back and affect climate. During the sampling procedure, what they do is they gather information about the number of trees that are in forest plots, the size of those trees, as well as other site level factors. They also take tree core samples, and many of those tree core samples get sent to us for processing. Tree ring data provide us with sort of yearly estimates of carbon storage. In years where there's not very much rainfall or not very much moisture, the trees generally don't grow very well, and so they don't grow very much in our measurements of the tree rings. And so that means that there's not very much carbon taken up. When we go into the lab, we take our sample tree core and we look at it under a microscope. And we count the number of rings first, so we have an idea of the date of each year. And then underneath the microscope, we measure the width of each ring. The low growth, or a valley in the tree ring growth time series, corresponds to a year that has low precipitation, whereas a peak in growth might be a year that was extremely good for tree growth, so a year that got a lot of rain and a lot of sunlight. Peaks correspond to times where trees are able to grow more and store more carbon, and the valleys correspond to time periods where the tree does not store as much carbon. So we use those tree ring measurements that we took in the lab, and we unite them with our forest inventory data, which provides us with information about the number of trees in the stand, how big those trees are, and our goal is to try and quantify this relationship between annual tree growth and climate sensitivity, and maybe how that varies across different types of forest stands. And so this allows us to not only try and predict how forest carbon storage and forest growth will respond to climate change, but also maybe make some management decisions that can help optimize forests for carbon uptake in the future and for climate resiliency.